Thanks everybody for showing up today at the end of what I hope has been a very productive week for all of you. I know this is probably at the last or one of the last sessions you'll be attending, so I very much appreciate you taking the time to be here. As the slide says, my name is Todd Golding. I'm a partner solutions architect focused on the SaaS specialty. And last year I did a few sessions at reInvent, and we really focused more as part of those sessions on sort of a broad set of principles and SaaS sort of objectives, and looked at pros and cons of different partitioning schemes, and tried to give everybody sort of a real broad view of the landscape of SaaS. And for some of the folks, I think that was a really good experience, but also we listened to feedback, and I think we decided this year to come back and say, could we do something more targeted? Could we really do something more focused that looked at a specific SaaS implementation and said, instead of sort of discussing the fundamental principles, show me a SaaS solution that's been built. Like, dig into a single solution, and yes, that solution will be one example of how you'd build one, but I think I might learn more from just seeing the end-to-end sort of solution and seeing all the pieces connected to one another. And so that is exactly what we're going to do here today, and I hope for all of you that matches what you think you've signed up for. So this will be actually a reference to a solution we've actually built that's out there that you'll be able at the end of this to go out, download, and so we'll certainly try to be deep as we can be today here, but my hope would be that we'll sort of give you enough of the framework for what's here that you can then go out, download the solution, and there's a 40-page PDF and a bunch of source code and a whole environment you can install and stand up on your own, and then take sort of the knowledge that comes out of this and use this to dive into that example. Also, just for a little more sort of set the stage here, this is a 400 level session. So the assumption is you're coming in and you have some orientation, some knowledge of SaaS. So things like data partitioning and tenant isolation, these are not hopefully new concepts to you. Also, we're going to dig a little bit into the code level. We certainly aren't going to crack open the IDE. We won't have time for that. But we are going to have slides with some code on them, and we're going to walk some of the sequence of the interaction between the application services to give you a sense of what this is all about. My hope is when you're all done with this that even if the example doesn't directly map to your existing solution, that this will be a foundation that will let you take some of these ideas, figure out how to lift them, see how they sort of work with the different AWS services, and leverage them to the best of your ability and whatever solution you're building on your own. So, enough caveats. Let's dig in a little bit here. Obviously, before we can sort of dig into the implementation, we need some kind of blueprint for what are we really going to build here, what are the moving parts of it, and sort of establish some kind of landscape for our discussion. So, I'm going to start with, thank you, clicker. We have to, obviously, anything we're going to do in SaaS is going to be a multi-tenant solution, right? And this particular multi-tenant solution we're going to look at here is what we'd call a pooled solution in the world of SaaS, which means all the infrastructure resources are shared by all the tenants in this environment. So when we look at storage, when we look at compute, and we look at all the moving parts of this, the idea is that all the tenant data is shared in that environment. DynamoDB, for example, when we look into DynamoDB, the items in the DynamoDB tables are going to be all the tenants' data commingled. And so a lot of the policies and the approach and the strategy we'll take in here will be driven by the fact that we're a pooled environment. If this were siloed or one of the other flavors, the dimensions might look a little bit different. And the first step we're going to look at is the onboarding piece of that. And for most people, this is just, hey, you go in, you sign up, you register. But if any of you have poked at SaaS a lot, you'll find that onboarding ends up being one of the most intensive parts of a SaaS application. If you think about everything that has to get provisioned by somebody just signing up as a tenant, and all the underlying configuration and the setup of a tenant, setup of their identity, setup of their policies, that's all part of the onboarding experience. And we'll spend a fair amount of time, not a huge chunk of time, but a fair amount of time looking at that to get a sense for what does it mean to automate all that inside a SaaS solution inside of AWS. Once we deal with onboarding and we have all the bits of that, we'll look at authentication. This probably should say authentication and authorization. And we're not going to look at just like, what does it mean to authenticate a user? I think most people are familiar with identity providers and what it means to authenticate. When I look at this, this is really more about what does SaaS do to authentication? what is it? Because to me, you can't just use vanilla out-of-the-box identity and just plug it in for SaaS. You have all kinds of additional considerations that are overlaid on top of this. In fact, I did an entire talk this week earlier. In fact, for some of you there, hopefully I warned you then, lots of this will overlap with that talk because identity is such a fundamental part of SaaS. And in fact, you might be surprised that we'll spend as much time on identity as we do in this talk because identity weaves its way through all the layers of our architecture. It affects the way we implement the app services. It affects the way we implement the partitioning. You'll see its story all over in here. So yes, I didn't want this to be an identity talk, but it's really hard to talk about SaaS without weaving that into the discussion. Finally, we'll look at, okay, what does it mean to be a developer and write the actual application services that are part of this? In this case, we're going to have an application that's decomposed into a series of microservices. And we really want to, at this level, just say, what does it mean as a SaaS developer to build a microservice that's multi-tenant aware, that thinks about all the things that they have to think about? But also, what do we do to make this a good developer experience? Like for the person writing these services, how do we shield them and hide them away from the details of multi-tenancy so that we're as efficient as we possibly can be? So we'll look at that bit, and then obviously, we're going to look at storage partitioning as part of this as well. Like, how are we representing data? And I said this is pooled. In this case, how are we representing pooled multi-tenant data? And in following with sort of best practices of microservices, each of these services, not shown so visually well in this diagram, each of these services are encapsulating access to whatever storage is on the other side of them. So we'll look at that whole experience. We'll look at how that's affected by identity and so on. And then the bit we'll look at and spend a fair amount talking about that is another area that gets overlooked is tenant isolation. I was doing another session earlier this week, Tuesday, and I was in a room full of developers who were SaaS developers, and I said, how many of you are sort of just relying on authentication as your entire sort of isolation scheme? And almost 3/4 of the room, their hand went up. Like, that's the definition for a lot of people. Like, okay, I challenged you at the front door. I made sure you were who you were. And I know your identity well enough that I'll just be sure in code that nothing gets crossed. That's not enough in a SaaS environment, really, right? Your customers and your business, really the lifeblood of a SaaS business, demands that you keep really firm boundaries between your tenants. You can imagine what would happen in an environment where one of your customers accidentally got access to another tenant's resources or their data. That can be like a fatal blow for a business. So even though it doesn't come up in a lot of our conversation, we spend a lot of our time in the universe of SaaS talking about what strategies can we have beyond authentication or connected to authentication that we can use to enforce this isolation between tenants. Now, the last bits here on the slide are more about operations and bits of this, metrics analysis, management, billing. I would love to have a bigger chunk of time here and be able to talk about those as well in great depth, but I don't, in an hour-long session, we can't really dig into all the operational bits, but I want to be sure I say that those are every bit as important as the application bits of this equation. And I would definitely go look at the other talks we have. We did another member of my team, Judah Bernstein, did a whole talk on like tenant health and tenant metrics earlier this week. I did a whole talk on metrics and those bits. So don't think those don't carry a lot of weight. We just don't have time to dig in today. We'll touch on a little bit of billing. We'll touch on a little bit of metering, and that's about it. Okay, so what's the stack we built all this with? And it's really hard when you're building a sample and a reference application to say, how can I find a set of tools that are somehow going to resonate with everybody when the audience is so large? But we tried to pick what we thought was a set of tools at least that would have a reasonable chance of matching some of what people are doing. We leveraged AngularJS as our client already, probably since AngularJS. You can imagine, Ember and React and all these other sort of tools are showing up over there. So we'll probably have to continue to introduce new clients to give people an idea what they look like. But the client and the Angular bits of this actually are all just deployed on an S3 bucket and following sort of general AWS best practices for deployment of a web app. The next piece in the puzzle is the API gateway. And there's a specific role the API gateway plays in this implementation that we're going to dig into the code of. But I also want to say that in general, if you're building a SaaS solution, you should use some kind of managed gateway as part of your API. It doesn't have to be AWS's gateway, but in general, if you think about what SaaS has to do, you often have really serious throttling needs. You'll have tenants at different tiers, so a basic tenant should be throttled differently than an advanced tenant. Another thing is generally you'll find yourself exposing some kind of public API to this, and you get to rely on the gateway for issuing keys and doing all the heavy lifting of exposing a public API. But in this specific example, we leveraged something called a custom authorizer with the API gateway to add a layer of security at the API entry point. That was another layer of security in our solution. So we'll dig into what that looks like. Then on the back end, we basically have a bunch of Node.js Express services. And we built this very simple order management system. It is not meant to be like this very robust, you could go ship this order management system kind of product. It's meant to just include enough services that you could get a sense of what it means to implement a system in this model. So you'll see order management and product management services, but then a whole bunch of other services here that are more about how do you get a tenant on board, how do you register them, how do you deal with the identity bits of this. And you'll see a lot of these are using DynamoDB in a multi-tenant fashion. And these are all deployed in an ECS cluster and container. So very classic sort of microservices model. And then this last bit, I wasn't sure where to sort of snap it onto the diagram in a way that was useful, but we are definitely using Cognito as our end-to-end identity solution, and we're using many parts of Cognito in this solution. We're building another solution that is a mirror of this, that is leveraging Okta as an identity provider, just because we want to convey and demonstrate that this doesn't have to be a Cognito solution. You get certain nuances out of it with Cognito, you'll get certain nuances out of it with Okta. We want to definitely show variety in that respect. But today, lots of discussion of how Cognito was used. Okay, now you go get this, download this, you go to the page where you get the quick start, you run the provisioned environment to set up the whole environment to run your app. What is the underlying infrastructure that's going to get provisioned as part of this experience? Well, what you're going to find is that we really, like all the quick starts for the most part on AWS, are following just a traditional best practices, high availability, scalable sort of architectural pattern. So you'll see we've got a VPC, and of course it's a multi-AZ VPC, so we get the high durability of multi-AZ. And then at the front, like we said, S3 API gateway and this Lambda function that is our custom authorizer as the entry points to our environment. And then we obviously have to have public and private subnets. It's just part of conforming to best practices. So we've got a NAT gateway that is our public subnet, and then that's load balanced into the private subnet that's going to host all of our actual application services. And finally, there's our app services all running in an ECS cluster, auto-scaled, and so on. So probably any of you have been working with AWS for a while, seen this looks very much like the blueprint of any HA sort of architecture you'd see on top of AWS. Now we can start shifting into onboarding. And we want to look at two views of onboarding. I thought about leaving this slide out, but I think there's something important it illustrates because it's still not code yet, which is where we really want to get to. But this illustrates some important points that I think here, which is this is the onboarding experience you'll see if you just go run the app, right? So I go out like any other onboarding process. I put my name and some of the bits in. I tell it a little bit about my SaaS configuration, which tier I am, things of that nature. I get the success message saying, hooray, you're going to get an email. The system emails me and says, here's your temporary password, go log in. I go to the system, I log in. The system says, oh, you're a new user, go change your password. Something we've all done a million times. But the reason I put this here is because the code behind this, when you go download the sample, you're not going to see a bunch of code that's doing all this work because Cognito is doing most of this work for you. And so I wanted to point out the fact that like sending the email, the configuration of am I MFA or not MFA, what my password looks like, am I going to be challenged to resupply a password again, all of that is orchestrated by Cognito. And it's one of the upsides of that. And by the way, the other providers have their own way they orchestrate it. But the good news is it's not really part of the solution. You have to build a whole lot yourself. Now let's actually go look and see what the services under the hood of that experience are doing. Because if you remember at the outset, I said, hey, there's a whole lot to this onboarding process. There's a lot you've got to do here, and there's a lot of heavy lifting that you may not be considering. Let's talk about it. So I push that register button. User says, success, you registered. What's that doing under the hood? Well, the first step, obviously, it's going to hit this tenant registration service I have, REST entry point with a reg on it. And now this tenant registration service is going to be the orchestration of all these moving parts that we have to create as part of onboarding. And there are three major legs of that orchestration part. First of all, I have to create the user and the identity footprint of my app. So yes, you signed up as a user, I got to get you in as a user, but I also have to provision all the mechanics that are necessary for all users of the system that are going to need identity of themselves. The other piece of this I'm going to have to provision is the tenant itself. Like, the tenant is an entirely separate construct. We have to configure and set up the tenant. And the last piece of that puzzle will be the actual billing interface. So let's walk those three legs and start with the user and the identities. Well, tenant registration calls our user management service, and then that user management service is going to create all the things needed to both create the user and create the identity profile. So what that does is, the first thing it does is it goes out to Cognito, and it says to Cognito, I'm going to create all the pieces that are needed there for Cognito to support the identity profile I want. And there are lots of pieces of that. The first thing I want to point out here is that we're using Cognito in this example as an OpenID Connect provider. And OpenID Connect is implemented by tons of providers, but there's some real goodness in the OpenID Connect implementation that let us take the traditional notion of sort of identity and bind to it the notion of tenant identity, right? Because what we really need out of identity isn't just who you are. We have to always know who you are in the context of the tenant you're associated with. And that's the extra piece we're going to leverage out of OpenID Connect to make that happen. So when I finally get into the hood of this, and you'll see what it's provisioning, well, the first thing it provisions is a user pool. For those of you who haven't used Cognito, user pool is just a grouping of users, and the good part of that user pool is it lets you actually configure policies for each one of those policies. So MIMFA, what's my password policy, all those things. So what we've decided here is we're provisioning a user pool per tenant so that you can then configure those policies on a tenant-by-tenant basis. The other piece we have to provision here is an identity pool. So Cognito has a federated identity model, and so you have to bind the user pool to a federated identity. Then, of course, we have to actually provision the user, who is this user who just signed up, who is like the tenant administration user in your system. And then the last bit is we have to do these custom claims. And this is all related to that OpenID Connect. OpenID Connect has this notion of I have a standard set of claims, and then I have this ability to configure custom claims. And those custom claims are where we're going to put the tenant attributes. And that seems like not such an important thing, but it's actually a very important thing as we go through the rest of this implementation. So in there is tenant ID, the role, the company, the plan you signed up for. All those bits are in those custom claims and become a first-class concept in your identity solution. Now, most people would think, well, that's enough. You're ready. You've got your identity bits. But there's another piece of this equation. We said we want isolation, and the way we're going to get isolation is through IAM policies. So as part of provisioning this this tenant, we also have to provision all of the policies that are going to be needed for all the types of users. So while this looks like a user kind of experience, remember, it's provision a tenant's identity profile, and this means provisioning policies for every single type of user you're going to have in the system. So once we're done with that, we've got that part done. Now we can shift to, okay, it's successfully created. The other piece we have to think about is we're going to create some mapping between the user and the user pool here. And that's the only job of user management storage, is to be able to say, which user pool is this user with? Everything else about the user and their profile is stored in Cognito, not in that data that's managed by user management. Finally, tenant identity is created. So out here, we're going to create one entry in the DynamoDB table that is our tenant. It's going to have the tenant ID, the plan, are they active, inactive. You can imagine all kinds of additional configuration and policy data related to a tenant here. The important concept here to notice is once this is all in place, right, we're still only going to have one tenant. And so as new users are added for that tenant, no tenant is added. They're all just bound to that existing tenant that you created in this process. And I just wanted to show you quickly, because I said these custom attributes, these custom claims are important. This is a snapshot of a screen straight out of Cognito, and it just shows you at the end of the process, probably hard to read, but these are the custom attributes that were created to convey tenant ID, role, etc. Now, the last step in that trifecta that we couldn't fit on that screen was the billing bit of this. And there are going to be 3 caveats in this talk that I'm going to tell you are code that are not in the download you're going to get. Because these are all areas we're adding, but I think are very important for you to think about as you're building your solution. Billing is one of them. It's not in the download you're going to get. But I want to show you what it'll look like. So the last leg in this tenant reg is we're going to go out and we're going to tell some queue, hey, provision a tenant. Now, why did we do that in a queue? Everything else wasn't a queue. The truth is it all could have been a queue. We could have just had general good asynchronous sort of messaging. But there's a very specific reason I'm relying on showing a queue here, which is when you sign up for a system and you have built all this provisioning and somebody's gone to all the trouble to sign up and become a tenant in your system, you don't want to lose them at the billing step. So for me, I want this to be a very fault-tolerant sort of mechanism. So I put it in the queue and I say, yes, I've asked account to be created, but if that account doesn't get created for another hour, it's not going to affect the overall sort of tenant's ability to get in and start using the system. So I put that in the queue, and then I have a service that will essentially sit there, pull the message out of the queue, and then it will go to the billing system and say, provision that experience. And here's where we can say, okay, if that billing system isn't somehow ready now, we can have some kind of retry logic or fallback logic, and really make this as robust and sort of fault tolerant as possibly could be. Because for most of you, billing systems are often an external third party. Even if it's internal, it's some other system that's often outside of your control. So anytime I have an integration with a third party system or an outside source, I'm going to do everything I can to give myself fault tolerance on that boundary. Okay, so we've set up our tenants, we've done everything to onboard them. Now we're ready to actually come in and sign in and log in as a tenant. What's that look like? Well, pretty straightforward. You hit the web app. Now, what's not straightforward here is, in a lot of diagrams, this web app would redirect to the identity provider, and you'd immediately let the identity provider handle the auth process. But we made a choice, and I think it's a bit of a controversial choice in our implementation of this sample, to say, hey, we're going to use user pool per tenant. And as part of using user pool per tenant, before you can auth against Cognito, you've got to know what user pool is in, because all I have when you log in is your user ID and a password. I don't know which user pool to auth you against, and I'm not going to go look for all of them. But the downside of putting this auth manager in this cycle here is now I've introduced a point of failure and a point of scale that could be a challenge in my architecture. So it's a conscious choice, but we may reconsider whether or not that's the best way to go, or should we let the identity provider directly be that unit of scale, which means we have a different model for how we represent users in Cognito. Either way, that user manager, auth manager says, I need to be able to go figure out which user pool you're in. So I hit the user manager, I see, look up your user pool. If you remember in the early slides, we showed that mapping was created. And then I go out to Cognito and say, hey, is that user pool out there? Validate it's out there. Obviously, if it's not out there, we're going to come back and indicate, hey, you didn't successfully log in. But assuming you found it, then I'm going to go auth you against the Cognito, and I'm going to get back, based on OpenID Connect, a JSON Web Token, a JOT token. And if you remember earlier, I obsessed over the fact that we were using OpenID Connect in these claims. This JOT token has in it, as one token, both my user identity and my SaaS identity. And that's going to now be accessible to all of my services, my partitioning, and everything else as it flows through the system. So if you learn nothing else from that diagram, focus on that token in the top right, because that's the outcome we really want. Now, application services. I'm going to write an app service. I need a product management service. It's going to say, go get me all the products out of your catalog right now. And I hit that, so my question is, okay, I'm multi-tenant. When I made this slide, it's like, what's different for me as a developer? When I wrote these services and we built them into this sample, what was different? Well, the interesting thing is, when we wrote the services, the whole goal was to say, I want these people to write these services as if they almost didn't know they were multi-tenant. Right? I'd like them not to be like adding all kinds of code into their solutions to somehow figure out how to resolve a tenant, figure out what policy needs to be applied. I wanted to make that as straightforward as it is. So I'm going to do little frameworky things here to sort of take common concepts that are about multi-tenancy and hide them away from the developer so that mostly they don't have to care about that stuff. So let's look at what that means as an example. So here I get a request in. You'll see that I get the get for my products. And in my header of my HTTP request, you'll see that I have an authorization header, nothing special about this. It has a bearer token, and that bearer token is that JOT token I've been obsessing over, right? It's encrypted, but it's in there and it's passed in as part of in the context of every call, and service-to-service interactions through my app services are all going to use this message as a method as a way of conveying the context of tenant and user as we go through them, with one of the key goals of being, I don't have to leave the service or go call something else to figure out which tenant you're part of. It's all in the header, it's all in the token. So now I get that, and now I want to just as a developer say, hey, go get all the items for this particular tenant out of the database. But I don't know who you are as a tenant, and I don't know what security credentials to call you with, right? That second part some people don't think of, right? Which is, oh, I just know a tenant and that's all I need to know. No, I still want a scoped set of security credentials based on our isolation goals that will scope your access to that data and make sure no matter what you do, you aren't able to see a piece of data you're not supposed to see, right? So as an example, let's say I just happen to, as a developer, manually put some tenant ID in, and I put in whatever tenant ID I want, I can go see anybody's data without any credentials there. But if I add the credentials to that equation, no matter what you put in the tenant ID, if you're not allowed to see that data, you're not going to be allowed to get to it. So that's the sort of two pieces of this puzzle. So what we did in this solution, which is what every developer probably does, is we said, let's take this and make some kind of library that is a library that will take care of sort of managing all these token-related things we need to do. So in the first one was, we just need a tenant ID. How do I get a tenant ID? Well, I want them to just be able to say, I've got a request, hey, token manager, go figure out what my tenant ID is. So you call this helper function on the token manager, it cracks open the request, it decodes it, it pulls out the tenant ID, and it returns that, right? And that becomes my standard way for everybody to get their tenant ID. And the truth is, in my data access layer, if I have one, I could embed all of this in the data access layer in a way that the client, the service sort of developer wouldn't even make this call. That could all be done in the data access layer. That's not true in the implementation. That's probably something I'd like to do to make it better. The other piece I said you had to have is these credentials. And we're going to obsess over these credentials a lot and how you get them. But essentially, on the surface here, you'll see, hey, I'll go to the token manager, again, give it the request, and say, you give me a set of credentials. Remember, I just have a token. I want a secret key and an access key that are going to tell me contextually, this is what you have to get to this piece of data. And so I'll make that call, and back will come the credentials, and those credentials will be the credentials I use when I go to the database and say, give me the items out of my catalog. So that's the underlying implementation. I think you could see how this would be minimally invasive to the developer of the product management service, but still be pretty nice in terms of, hey, there's some good multi-tenant values in there. Now, I wanted to just peek briefly into what's in that get credentials from token bit. And there's a couple phases to this. We're going to see code multiple times along the way for this. This first one is more about, hey, how do we just get those credentials back without how the mapping is actually done under the hood? So you'll see here this get credentials from token essentially drops in, look to the request, pulls the authorization header out of the request, parses out the token, decodes the token, and then there's a couple of calls that are made here. And these calls are all about our internal calls that we'll go into a little more detail on. But these calls, their goal is to essentially go out to Cognito and say, I have a token, I need the appropriate credentials that go with it to come back. Those credentials come back, and then those of you that are familiar with know this is just a callback function. You see it passed, update credentials passed in at the top. That's a callback function. And then at the end of this function, you'll see that I get the results from making this mapping, and I call the callback function, sending the results back. Wish we had a little longer to dig into this one, but you get the basic idea here, which is this guy's sort of isolated in a way doing that mapping for you that should be reused by everybody and from one spot. The other piece of security we want to add to this is this custom authorizer I talked about earlier. And this is, so right now what we looked at was inside the service, what were we doing to apply security? With the custom authorizer, I'm wandering out to the outer edge, and I'm saying, what am I going to do at the API gateway as another layer of security in my system, right? It's not that if I get security at one layer, I'm done. No matter what I want, I would love to put security at as many layers as I can so that I get this better sense that my security isn't going to fall down on me. So what this custom authorizer lets me do is say, hey, I've got this token coming in. It's got all this goodness in it. I know who you are as a tenant. I know you are as a user. And I can connect this Lambda call to your API gateway entry points and say, hey, for these REST entry points, I'm going to inspect what's in there, and I'm going to determine which methods you're allowed to get to and which methods you're not allowed to get to. And I will control access to your services so you never even get to a service if you're not supposed to be there. And if we look inside this, this is the Lambda function that we implemented. It's a snippet of code. It's a much bigger chunk of code. But you can kind of conceptually see what's going on here. The first thing we do is we pull the JOT token out of the incoming context from the API gateway. And then we construct a policy, right? A policy is the mechanism we need to convey back to the API gateway what methods are allowed and whether a method's allowed to come through or not allowed to come through. And so we construct that, and now we inspect the contents of the JOT token. And you'll see a line here where we look at is this JOT token an admin? We essentially look to see whether it's an admin. And if it is an admin, we set the policy to, hey, all methods allowed. You can access anything you want. If you're not, we constrain it to you can only do gets, and you can do one post, which is on this user's path. And then you'll see we do a context succeed, and it goes back. And that policy is then used by the API gateway to control access. To me, if you didn't even have access, say you didn't do all the bits under the hood with the token and the mapping that I talked about earlier, you could at least include this on the outer edge as a nice way to say, let me at least inspect the token enough to say they can't get through the API unless they have the right prips. Now, data partitioning is kind of interesting because when I put this together, I thought, well, data partitioning, there's going to be a lot to say here. There's a lot. But data partitioning ends up being not so complicated in this. The interesting parts of data partitioning are more about how we control access to the data than how we actually partition it. But just if you look at what we actually implemented in this solution, in a pooled model with DynamoDB and a shared table, we're essentially going to use the partition key of DynamoDB for each tenant ID. So now when we access data, we first have to fill out the tenant ID as the partition key, and then your range key will become whatever your prior top-level key would have been. So in this case, product ID. Now we've also implemented, and this is caveat number 2, this S3 bucket. Now we're in the process of adding this to the solution. It's not in the version you'll get, but you'll see it soon. But we're adding S3 bucket with partitioning to show you what it looks like, but also because it's kind of nice to add product images to our catalog in a way that you can see that. But we also want to show how object tags can be used as a mechanism to partition data in S3. But the partitioning of this is not nearly as important as the fact that you probably put helpers between each of your storage units that basically hide away the details of how you're partitioning the data. So the best example I could give here is, let's say we're using this pooled model for data for this DynamoDB table on the left, and tomorrow we said, you know what, based on our feedback from customers or some operational profile we're seeing, we really need that to be siloed data now. It can't be pooled. We need every tenant to have their own table. Well, in that model, I would prefer that the app code itself doesn't somehow now have to go account for the fact that it's silo versus pool. I want that to be hidden away by whatever sort of framework or tool or library sits between me and the table itself. Now, this is the code that is sort of the second step in acquiring the data. We talked about how you get the credentials for the code, and that's the first line of this. But then now that we have the credentials that come back from that come back in this callback function, what do we actually do to call DynamoDB to get the data from the tenant in that context? Well, the first thing we have to do is populate a set of search parameters, pretty straightforward. What table are we getting it out of? And we're looking for a value where tenant ID equals a specific value that's based on the tenant ID, which is a context I already got outside the scope of this function. And then the line that seems so innocuous, but is the whole reason this slide exists, is this construction of this DynamoDB helper. And the DynamoDB helper really just gets constructed, and then we use it to call the query. You'd say, why is that line relevant? Well, that line actually ended up being a huge source of challenge for us when we built the sample solution, because you'll notice the second parameter it takes when I construct it takes these credentials that comes in. Well, we initially started by leveraging all kinds of third-party helpers that are out there for DynamoDB. And what we found is a lot of those solutions rely on a credentials configuration that sort of leverages the AWS general ways of like globally configuring your API config and all those other bits, and then they just suck it in as the context for the credentials. And even when you try to override them with some specific set of credentials, you don't successfully override them. So you end up with a broader scope than you ever want, or you end up with one notion of credentials. So we actually had to build our own DynamoDB helper wrapper here around the API with the expressed goal of saying, on a call-by-call basis, you're reacquiring and reapplying the credentials for every single call. And that makes sure you have the scoped access to the data that you need. I'm hoping there's a better answer to this ultimately, or a third-party tool that lets us do what we want so that it fits more with the normal what you're doing. But that's why all that code exists if you go look at it. So I haven't really answered the question I posed at the beginning, though, which is, I said we had identity, we have these IAM policies, but how are those IAM policies controlling my access to data? So far, nothing you've seen in the code would have changed anything about whether you could have just put a different tenant ID in and went and seen somebody else's data. And where this gets applied is in the way that you use IAM policies. That's part one of the problem. So let's look at the IAM policies. Under the hood of the IAM policies that were provisioned, if you remember one of the early slides, I provisioned all those IAM policies. I've pulled one out here, and this is just one example of one of the many IAM policies that get provisioned for a tenant. And I also wanted to convey the idea that obviously these policies are per role policies. So this happens to be a read-only on the order table that is used for a tenant. But if I had an admin or a system admin or a different role, the privs would be potentially different. But in this one, it's read-only, and you'll see the actions are constrained to read operations only, no write operations. And then the real caveat is down in that condition down in the bottom. In that condition, you'll see that I use leading keys. And you'll see specifically in the leading key, it's not so obvious, but that's a tenant ID. And what that says is whoever's running in the context of this IAM policy will only be able to access items that have that leading key value. And that's where the IAM policy enforces and controls that cross-tenant access. Now, the last piece of this sort of isolation and identity puzzle that is being used across all of this is a piece I sort of left out at the beginning. And it's a nuance that gets lost often in the implementation of this particular solution, which is, if you think about it, at the beginning we configured IAM policies and we configured cognito users. But there's nothing when you auth that suddenly binds that user to an IAM role. Those IAM policies just exist out there on their own. There's nothing in them in the policy that references the user, nothing in the user that references the policy. And yet somehow under the hood when we do this, the two get bound together. So let's look at how that works. And by the way, if you look in the code of the solution, because I didn't write this part of the solution, another member of the team, Judah Bernstein, worked on this. And in fact, I came back to him this exact question, like, I'm not seeing where that mapping's happening. And if you look at the user pool when you configured it, you configured these custom attributes. One of the attributes you configured was role. And then when you configured the federated identity, you gave it the user pool and the application ID. But the secret sauce of this moment is these role matching rules. The role matching rules allow you to configure a matching from an attribute to an actual set of policies. And those role matching rules, which are enforced and applied by Cognito itself, are the thing that make this binding that is not so obvious. Now, if we look in the code that is the code that underlies this, and we were to go back to the provisioning code that was the onboarding process here, and we looked at where we were creating all those policies, this is a snippet of the code you would have seen. You see here that I'm defining each of the roles, and you'll see basically this sort of expression here where you say the role equals some value. In this first top one, it looks like it's a system user. So if the role is a system user, here's the particular role I want it to bind to. If the role is a support-only user, then it binds to this particular role. And then there's obviously a whole collection of these that describe these. And if you open the Cognito API console and you go look in there, you can actually see these matching rules. So to me, something that Cognito can do because it can bind to IAM in a way that's kind of special, that gives you a little bit of a way to short-circuit the process. The last piece of this is the actual code that you run at runtime that sort of forces this mapping to happen. So if you remember at the beginning of this, we looked at some code that said get credentials from token, and I said, oh, there's a couple of functions in there that translate your ID token into the appropriate security credentials. Well, under the hood of one of those calls is this particular call, get credentials for identity. And this get credentials for identity takes, first of all, the federated identity pool ID, and it just takes your token. But inside your token here is your role. So the role that's needed to make this mapping is already in there. So then when we get to this Cognito API call here, which is get credentials for identity, and we make that call and we pass in these parameters, Cognito will look inside of it. It will see what role you are. It'll evaluate those role matching rules, and it'll find the appropriate policies that are there, and it'll construct a new token for you that is a token that is now scoped by that role's set of policies. And just because I think it's kind of convoluted, I tried to have one last slide that connected all the dots on this, right? So your service under the hood at some point says get credentials for identity, passing that ID token. At the top, you can see the ID token, the cracked open JSON version of that token that has the role that you're interested in. Then Cognito will go do the matching. It returns the scoped credentials, and then eventually you have a secret key and an access key that are there. Now, if you were not using Cognito here, you could still map the role to a policy, but now you'd use the assume role API that's out there. So now it becomes your job, do the assume role, and it goes through this, and you'll eventually get back an STS token that is the equivalent of the credentials that we get at the end of this process. So again, Cognito has got some nice little bells and whistles here that make this a little easier, but totally achievable outside the context of Cognito as well. Now, everything we've talked about so far has been in the context of the server. How does the server implement storage? How does the server rent services? Because I think that's where most people are focused on in terms of how to build all this. But there is a multi-tenant sort of universe that we have to think about for the client. And I don't want to spend a ton of time on the client, but I think it'd also be wrong to leave the client out of this, because it plays a role in how does it deal with identity, how does it map it into the implementation. But I also think it's very specific to individual applications and even technology stacks. You know, .NET, Java, Angular are all going to approach this probably slightly differently. But you do have to think about, hey, my app, and specifically this app, has one application that is addressing the needs of system users, tenant users, and all the different variations. There's like six or seven variations of users that it has, and each one of those has a slightly different experience. And we did that on purpose so that you could both see the IAM policies applied, but you could also see different flows in the application go on and off based on your privileges. So we have an admin experience where somebody can go out and view all the tenants in the system. They can deactivate and activate tenants out there and control whether a tenant's allowed into the system or not into the system. They can create new system users with different sorts of views. So you can have a system user who sees all tenant data, or just somebody who's like read-only and can go out there and maybe is more of a support role kind of thing. And then we have a tenant admin. A tenant admin has a very different experience because tenant admin's allowed to create other tenant users. They're allowed to see metrics. They're allowed to configure policies that are not there. And then we just have a basic tenant user who's somebody who just consumes the application. And you can imagine even different roles at that level. So what's that look like under the covers? Like, how are we applying both security and controlling like the paths through the application? Well, if you're familiar with AngularJS, although there's no magic here, we essentially want to say, hey, when we authenticate, yes, we're interested in what that token is for all our authorization through on the server side, but on the client side, we still want to pull that token out and pull the data out of that token for client-side use for pieces that we need in the context of the client. So here you'll see this thing called root scope, and root scope in AngularJS is just think of it as a global context that I can reference throughout my application. You'll see this token that comes back, response.data token there in that second line. That's my bearer token that comes back from this. I have to decode that token. I use this little module called a jot helper that goes out and decodes it for me. And now once it's decoded, I can just poke into it and pull out the attributes that are interesting me on the client. So I pull out the name because I want to display your name on the screen somewhere. And then more importantly, I pull out your role. And when I pull out your role, I'm going to leverage your role in the app side to control all the paths that you can get to. And I don't want to dig into this one too much because it's so specific to Angular. But what we did here is say, okay, now there's a set of policies that determine on the client which paths you can navigate to and which screens you can see in which contexts. And so we created this centralized function off the root scope that was isLink enabled. And what isLink enabled does here, and as you look at this function, it takes a view location. And that view location is essentially the path you're trying to navigate to. Are you trying to get to tenants or users or orders or products? What are you trying to navigate to? And then says, I'm going to go look at your role that I got from the token that came in and evaluate whether or not you're allowed to see that path in the application. So here you'll see, if you wander down a little bit, if the view location equals /tenants, I'm going to go look to see, this is a little bit of a helper function because I have to squeeze all this on the screen. I'm going to go look to see if your role actually is compliant with the system user. And if it is, I'll return true. If it's not, I'll return false, and that's how I'll control whether or not that link is there. So this isLink enabled ends up being referenced in our HTML now. So if you get all the way out to the HTML side of coding the HTML bits of this and say, I've got this link that lets you get to this on the screen, now I'm going to use these Angular notations like ngIf is just an Angular notation for invoking the Angular framework to invoke this if clause. And this if function is going to call my isLink enabled function that I showed you just a second ago to say, hey, I'm interested in the /users path, the /users view location. Am I allowed, based on who I currently am, to get to that location? And then if I am, I'll use this isLink active to be able to like deactivate or activate that link. I'm less worried about the HTML bits of this and the Angular bits of this. What I'm really worried about, and maybe I could have just presented, is this flow that is at the bottom here, right? Really, I just want to say, whatever technology you're using, go out there, extract the role from the token that comes back, define some process centralized process, hopefully, for evaluating somebody's access privileges, and then use whatever mechanism that's the lightest weight mechanism you can in your HTML to enable and disable that access. The most important thing here is whatever I do on the client, that's just client's notion of security. It has nothing to do with the server side of security. So if somebody somehow implements something in the client here and enables a path that they weren't supposed to enable by mistake, when that token finally gets to the server side, I don't really care about any of that. I'm still going to do all those things that we talked about. I'm first going to look at the API gateway level and with the custom authorizer, see if you're allowed through. And then even when you get all the way into my service and you try to access some resource, I'm going to use privileges to be able to make sure that you can't get to a resource. So this is where I'm saying isolation sort of wanders across this whole experience, even when you don't intend for it to, potentially. Third caveat, metering is not currently in the sample solution. Last of the caveats, metering is being added to that solution right now. So we ultimately want to see metering and billing both added and this S3 partitioning. Those are the three that are like under development but not released yet. But I still feel like you can't build a SaaS system and not talk about metering, because metering is at the core of both billing, but it's also at the core of a lot of other analytics potentially. And so I showed a sample here of what the metering sort of solution we're looking at right now. And you'll see our functions come in, our services are accessed through the API gateway, like we said. We are basically instrumenting them with a module here. Could be an agent, could be anything you want that is appropriate for your technology. And those metering sort of modules are responsible for surfacing the metrics of our system. And you'll notice they consult this tenant manager in the middle, and that tenant manager has configuration, and that's because metering can be tenant specific. I can have specific SLAs for each tenant, I can have configuration that will affect your metering experience. So these metering agents have to consult that configuration to determine what to do when they're metering your data. But essentially after that, if I've got some way to surface the metrics, now it's just going to go through some mechanism that's going to aggregate that data. So I'm going to go to Firehose here. I'm going to go to aggregate it, to collect it, put it into Redshift, and then I'm going to put some billing aggregation piece of this that will actually pull out the metrics that are most relevant to the billing environment and push them. Some billing systems pull, so it could be the way, but in this case, I think it'll mostly be push. We'll push those metrics to the billing system, and then the billing will be able to generate that bit. I mostly don't want people to overlook the need for this as part of their implementation. Now we wanted to be able to say, well, we got this system admin experience, this tenant admin experience, what's the difference between their experiences? And so we introduced the kind of a cheesy little dashboard, not very visually appealing necessarily, but it shows you the service health here. So as the services are all running, you'll see a little green chip boxes here. Obviously, if the microservices go down, you'll see red X here. And it was included here to say, this is a system admin's view of health. It's across all the tenants. And then we have these metrics down below, which are just how many products, how many orders, things of that nature. That was meant to be, hey, this is both a system and a tenant admin view. And it was a way to sort of show you what would it be, what's a different experience potentially like, especially on the client as we look at applying different roles. But nothing exotic about it, just something I wanted to call out because it's an example of something I think you should include in your app. Now, what are the takeaways from all of this? What are the bits I'd like you to potentially leave with? Well, I hope you realize after you've seen all of this and all the discussion of roles and isolation, yeah, we were supposed to be here to talk generally about architecture for SaaS, and that we had all this discussion of identity and the way that identity gets bound and gets applied as we access data, but that is what multi-tenancy is all about, right? Multi-tenancy is like, how do I get tenant context and how do I appropriately apply it as I access data, as I implement my services, and all those bits, and how do I provision an experience at the beginning of all this that supports all of that. It's more fundamental than a lot of people think. Hopefully also by looking at IAM here and see that we use policies, especially in a pooled model, how we use policies to control scope looked like a powerful construct to you. I personally love seeing this and love using this in my multi-tenant solutions because I feel like no matter what a developer does, no matter what somebody on the UI does, when you finally get down to accessing that resource, I'm going to have some confidence that somebody can't cross a boundary. So I'm going to invest the time and energy in building those IAM policies. I will say, as you go service to service, the way that you partition is different, and because the way you partition is different, the way you build those IAM policies is also different. Silo versus pool is different. So you have to think about that as you come up with a scheme for building your policies. Just a general goal, I've already beat this one to death, but hopefully it's very clear that we want to keep all these details as far away from the developers as we can. We just want to write the app, continue to write the app, and we don't want to feel like, hey, because we're in the multi-tenant universe, suddenly writing an app got way harder. No, we want to solve these problems, solve them right, but then mostly just have them be baked into our infrastructure, baked into our approach, in a way that we can just charge forward and feel good about the fact that the system will support this. And then we'll focus more of our energy on scale and how we deal with multi-tenant load and things of that nature. Those will always be huge operational challenges and part of another talk entirely. This one we didn't really hit on a lot, but if you notice in here, we had a lot of discussion of system users and like you can see all the tenant data, and then we talked about tenant users and what does it mean to be a tenant in the system? And even within those, there are different flavors of those things. A lot of people don't even think about a system user when they come in, right? Like they don't think, well, what is it going to mean? How should we provision and manage the scope and access of our own people who have to touch the system? That becomes like everything's about the tenant. But these system users are more dangerous and have the more potential to do something you don't want them to. And they all should be sharing a common approach to how you're enforcing it. Like I want system users to have a whole set of IAM policies that are just their policies. Even though we didn't get to hit on metering here, I feel wrong not saying that these are key fundamental concepts to SaaS. And if you kind of make them an afterthought, they often end up being a lot less valuable than they could have been. and your billing ends up being a lot less interesting than it could have been. I love to see organizations, SaaS organizations, like struggling with what is the right thing we should bill on? How can we meter for that? How do we get better view of what tenants are doing in our system? I like that to be an early discussion. I don't want you to sort of put that off until the application features are finally getting rich. And then finally, I want you to work multi-tenant. We had this very early diagram where we showed onboarding, app services, storage. I don't want you to work that in silos. I mean, the best solutions to me are ones where somebody says, oh, we're building a brand new SaaS solution. What's your first sprint? Somebody logs on, somebody says, write a product to the catalog, somebody writes the product to the catalog, and then you get the product back out. And that's it. Like, that's a great first sprint. Do you know how many pieces of this you have to get right to make that work? Like, all those policies have to work. Can I go verify they can get to it, can't get to it? How do I resolve the tenant ID in the service? How did I resolve those bits? If I just do that as my first slice, then I can start adding all the depth that's needed there. And by the way, DevOps isn't in this discussion. I'd make the same comment about DevOps along that path as well. Finally, resources. I promised a link to where this is at. You can see it's SaaS Identity and Isolation with Amazon Cognito. It says Identity and Isolation. I sometimes wonder if we rebranded it because it's truly a full reference SaaS implementation with microservices. But obviously, as you hear from the talk, Identity and Isolation are a big part of that discussion. There's also just a source repo, and if you do nothing else, you can just go down get the PDF out of the repo. Nice big document there to cover that. And then the last one is just general SaaS content. There's a whole bunch of SaaS content out there if you go look at this last link and around all of these topics with a lot more depth around them, especially for the areas we couldn't get into much detail on today. And that's it. Thank you so much.